Okay, everybody. Well, first I want to start off by saying that I miss seeing you today. It's kind of a bummer that we have to do this via video. I hope you all had a good weekend. So what I want to do is just make a short video for each section that we cover. So these are the notes you have in your packet. We probably would do more than just this section today, but I'm still going to just limit it to a lecture for 6.1, a lecture for 6.2. If you have questions, don't forget about the Zoom room. A bunch of you have done it, which is so easy. You just send me a message through Remind that says, hey, can we meet face to face? And then, no joking, with less than 2 minutes we'll be seeing each other. So that is always a good option if you're having questions on anything. And then don't forget your My Math Labs. They're due tonight at midnight. And then you'll have some more opening up today as well. So this section I thought was a nice transition from what we've been doing because there's really not a heck of a lot new. So what it's called is called systems of linear equations, and we're going to look at systems that have two linear equations. And the objective for this is to find out where two linear equations cross, because if they cross, then they have the same x that will give you the same y. And so these should be pretty easy for us since we know how to graph lines. So all I want you to do is turn off the video and go ahead and graph these two lines and see where they intersect. So turn off the video, graph the lines, and then turn it back on and we'll see how we did. Alright, so for this line, your slope is going to be 2 over 1, and it looks like the b value is 0, 4, right? So the b would be 4 for the y-intercept. So I'm going to start it at 4, and then I'm going to rise over, run. Rise over, run. And or you can go fall 2 and then go to the left 1. Okay, so I'm going to put my ruler down. I recommend using a straight edge on these so that you don't get any incorrect crossings. Alright, so there's my first line. And then my second line, let's see, I'm going to start it up. Looks like, I'll come down here, my slope is negative 1 over 1. The y-intercept is 0, 1, so that b value is going to be 1. Label it that way. Okay, let's label it that way. So, I'm going to start it at 1, and then I'm going to fall 1 and go to the right. Fall 1, go to the right. Fall 1, go to the right. And you're going to see pretty quickly that these guys cross. They intersect. So their point of intersection is the x value that gives them the exact same y value. So that point of intersection right there looks like it's going to be negative 1 of 2. And that's the solution to this system of equations. It's the x value that gives the exact same y value. So the ordered pair is going to be your solution. So you're going to make sure you write your value as an ordered pair. And this is what's called a one solution system, right? They cross at one point. All right, so let's flip. We'll play with some of these other ones. So again, I would stop the video. If you make a mistake, I put a little thing, an extra sheet of graph paper for you. But go ahead, stop the video, and graph those and see where they cross. Alright, so let's see, my m for this guy is going to be 3 over 1, and I'm going to start it, I'll just label the b. It's in order, you know, it's the y-intercept, but I'll just label it as negative 1. So I'm going to start up at 3. Nope, I'm going to start up down at negative 1. Hold on. Start down at negative 1. And then I'm going to rise 1, 2, 3, and run 1. Rise 3, run 1. Rise 3, run 1. That should be enough to give me a nice looking line. Okay. All right. So for the second line, it looks like my slope is going to be -2 over 1. I always put it over 1 so we can get the rise and the run. And then the b value is going to be +4. So we'll start up here at 4, and then we're going to fall 2, and then go to the right 1. Oop, there's my solution. Fall 2, go to the right 1. Fall 2, go to the right 1. Alright, line that up. And then this is a 1 solution system. Right there's my point of intersection. So it looks like it would be the ordered pair 1, 2. So that to me isn't too terrible because you guys are really comfy drawing lines. So you're just going to draw 2 lines and see where they cross. So not so bad. Alright, so stop the video and go ahead and do the next 2. Like, take your time, stop the video, and try the next 2. Okay? If the line isn't in the form of y equals mx plus b, I recommend you take the time and solve for y out so you can find the slope and the y-intercept. So this might take a couple minutes, but stop the video, and when you're done, come back and we'll see how you did. Alright, I'm going to go ahead and solve for y for this guy. So we have 3x plus 2y equals -4. So I want that 2y all by itself. And I usually like leaving that x term in the front because we're so used to mx plus b. Okay, and then don't forget when you divide by 2, each piece gets divided by 2. So y equals -3x all over 2 minus 2. -4 over 2 is just -2. Alright, so there's my slope. And then that b value where I start, remember the number and the sign can't be separated, so that would be -2. So I'm down here at -2. I'm going to fall 2, 3, and then run 2 to the right. I'm going to fall 3, run 2 to the right. And then you could also think about the negative being down with the 2, so that means you would rise 3 and then go 2 to the left, right? It just depends on where you pop that negative. That doesn't look right. 1, 2, 3, 1, 2. Right there's my point. Get rid of that guy. Okay. So there's my line. Alright. And then let's look at this guy. So here my slope would be 1/2 and my b value would be 2. So I'm going to start up here at 2. I'm going to rise 1 and run 2. Rise 1, run 2. Rise 1, run 2. That should be enough. Okay. Now let's put down my little straight edge. Line those guys up. You can see where they cross. It's pretty evident where they cross. Remember, we're ignoring that point. That was the wrong one. So ignore that guy. And there's my solution right there. So it looks like it would be -2 up 1. -2 up 1. And all the answers are on my math library are going to fall right on the tick. So these aren't something that you have to eyeball or guess at this point, right? So -2, 1 would be my solution. So down here, hopefully you took the time and solved for y. Alright, so I'm going to go ahead and do this guy. So I have 2x minus 3y equals -6. I'm going to subtract 2x from both sides. Alright, and then I'm going to divide everything by -3. Remember, we're going to divide each piece by -3, so it keeps it separate. You can leave it as a negative or over a negative. A negative divided by a negative is a positive, so I'm just going to write 2/3 x, and then a negative over a negative again is a positive, and 6 over 3 is 2. So let's plot that. So I'm going to start it at 2, and then there's my slope, so I'm going to rise 2, run 3. Rise 2, run 3. Okay? Again, this is just a thick piece of paper. You don't have to have a ruler to make a straight edge. Just fold a piece of paper in two and you'll have a nice thick edge. Alright, now the red one. Where should I do that? Maybe I'll do that up here, okay? So I've got 2x minus 3y. Oh, I just did that one. Let's try x plus 3y equals negative 3. So if I subtract x, we'll get 3y equals negative x minus 3. And if I divide each piece by 3, I'm going to write it down right over here. I'm going to end up getting y equals negative x over 3 minus 1. Now it's weird to look at the slope for that, but if you have negative x, bring it down over here, y equals negative x over 3 minus 1, there's really a 1 there, right? A 1 understood, so the slope would be negative 1/3, and that b value would be negative 1. Do y'all see that? It's kind of sneaky. It's a little sneaky part. So we've got negative 1, and then we're going to fall 1 and run 3. Fall 1, run 3. All right. Line that up a little bit. Okay, so there's my points. Okay, so it's not, let me see, let me check this one out. Maybe this wasn't such a great graphing job. So if I went down to 1, 2, 3, yeah, I think this is where these guys were supposed to hit, right here. Right, so the slope was 2, 3, so if I fell 2 and ran 3, it would be right there. That's where they cross. So that solution looks like it would be negative 3, 0. All right, I'm hoping those make sense, right? You shouldn't have any trouble doing that with my math lab. That's looking at it graphically. Now, there we go. They're also going to give you problems on my math lab with tables and ask you to solve these, use these systems using a table. And so instead of showing the graph, they're just giving you some points. So they said, okay, these are some, when x is 0, y is negative 3. When x is 0 for that second line, y is 7. And you can check it, right? If you put 0 in for x, you'll get negative 3. If you put 0 in for x here, you'll get 7. So for that x, we have 2 different y's. That's not going to be a solution. All right. So for this one, if we put x equals 1 in, if you put x equals 1 in this, you'll get negative 1. If you put x equals 1 in this equation, this line, you'll get 4. So when x is 1, not the same. But you see here, if we put 2 in, that'll be 4 minus 3 is 1. If we put 2 in here, that'll be negative 6 plus 7. That equals 1. So this is the solution right here. So if they ask you to write it as an ordered pair, when x is 2, y is 1. It's just with the table, right? So you're not looking at where they cross. You're just looking at what x will give you the same y. So that's not too terrible. All right, so let's check out this one. Do you see it? So you're trying to find the x value that gives you the exact same y. So where's the repeater y? Right here. So here's your solution. When x is 1, y is 3. And you can check it. Put 1 in there. So that'll give you 3. Put 1 in there. That'll give you 3. So imagine if I graph these lines, they're both going to go through the point over 1 up 3. So that's where they cross. All right. You guys take a pause and see if you can see this one. So what's the x value? It gives you the exact same y. Yeah, this guy right here. So when x is 3, y is negative 4. That's not so bad, right? That's not bad. Okay. So that's if they give you tables. And now let's look at, remember we talked about, let me flip, I'm going to show you what I mean. We talked about different types of lines. They can cross, they can be parallel, And then, do you see how it's on mine it's purple? The red and the blue graphed together and made it purple. So this is what's called a one solution system. Okay, and it's, some books will call it consistent. A consistent system. So you've got two lines that cross. This are lines that are parallel, so they don't cross. So these are parallel lines don't cross. So there is no solution. And this is often called an inconsistent system. And then this, it's hard to tell, but the red and the blue come together and make purple. So this system are two lines that are exactly the same. So here, the two lines are exactly the same. Therefore, every x yields the same y. So there is an infinite number of solutions. And this is what's called a dependent system. So you've got a consistent system, you've got an inconsistent system, and you've got a dependent system. I'll give you a minute to write that down. So now we're going to look on the previous page what it looks like when you're given these on MyMathLab. You'll notice right away, but sometimes they still want a graph of them. So if they want a graph of them, well then this is what it's going to look like. Alright, so on this page, let's go ahead and graph that one. That's already solved for y. So we're good to go. So m is 3. And the b value is -1. Okay, so I start with the red. So if we've got -1 here, and then we rise 3, and we go over 1. Rise 3 and go over 1. All right, so let's put this down. Catch those points. Oh, there we go. Okay. Now this one, it's hard to see it right now because we haven't solved for y. But if I bring this over here and go y minus 3x equals 5, and I add 3x to both sides, we'll get y equals 3x plus 5. Now sometimes when you're on a test, you don't even realize what you just did. Like you don't see it right away. So if we were on an exam, we would plot 5, and then we would rise 3 and run 1. Now we ran out of space, so instead of rising and going to the right, we're going to fall and go to the left. So I fall 3, 1, 2, 3. So if we put our ruler up, it's pretty evident, right? As soon as you step back, you're like, oh, these guys must be parallel. There is no solution. Okay, it's an inconsistent system. There's no solution. And then the last type, it's what's called a dependent. And again, it's hard to see right away that these are identical. So let's go ahead and draw it. going to start up at 1. I'm going to rise 2 and run 1. Rise 2 and run 1. Rise 2 and run 1. Okay. So there's that line. And then down here, let's go ahead and bring it over here. Let's go ahead and solve for y, because it's hard to see it right away, the way it's written, that they're the same. So I'm going to subtract 6x. And then I'm going to divide each piece by -3. Okay, so let's simplify that. So we'll get y equals 2x plus 1. And now do you see it? Do you see the m is 2 over 1 and the b value is 1? So if we came over here and actually did that, there's my b. I'll make a little there. And then we're going to rise 2, run 1. Do you see it? Do you see it? It's just going to be the exact same line. So if we drew that line, every single x has the exact same y. So this is an infinite number of solutions. Okay? And then the last little problem was something like on my math lab, so I thought we should do it. It's one of those pesky vertical and horizontal problems. All right, so it says find the solution set. So we know if it's x equals a constant, we have a vertical line. And just as a review, a vertical line has a slope that's undefined, because we can't walk up a vertical line. So this guy is going to be a horizontal line. And just as a review, the slope is 0. It's not rising, it's not falling, it's just this nice flat horizontal line. All right, so a vertical line that cuts through x equals 3 looks like this. Right? That in red. So here's my x equals 3. And a horizontal line going through y equals -2 would be like that. So they will have a solution. There's one point where they cross, and that point's pretty obvious, right? It's when x is 3 and y is -2. Okay, so I'm going to do one more video for the next section, but hopefully that makes some sense. If it doesn't, make sure you contact me through Remind, and we can see each other face to face, right? So give that a try, and also work on your My Math Lab, and give me a shout if you need some help.